Hi everyone, welcome back to the channel. In today's video, we're going to look at another worked example for differentiation. So here we have an example. It says, given this function, we have to find dy dx, right? So you see here, we've got actually a fairly complicated function going. We have a quotient here. So when we find the derivative, you remember you are finding dy dx. So you are finding the derivative with respect to x. Okay. So let me just write this out over here. I want to write it over again. It's quite a long one. So our numerator looks like that. And our denominator is made up of two different brackets. So initially when we look at this, you think to yourself, okay, you have a quotient, so possibly quotient rule, right? And quotient rule is your derivative is going to be f dash g minus f g dash over g squared, right? Where f is your numerator and g is your denominator. Now, if you start looking at what you're going to have put into each of these parts, it's going to get extremely complicated, because if you see your denominator is g squared, right? This bottom bracket here, it means that everything in this denominator has to be squared. And if you can just imagine, that is going to be a very big and bulky expression you're going to be working with. So maybe that's not the best way to go for it. Okay, so we're going to take quotient rule off the table and think maybe there's a different way we can handle this. And in fact there is. We can introduce logarithms here. So we can use logarithmic differentiation, because with logarithms you can then simplify this expression a lot further. Okay, so I'm going to say I'm going to introduce intro my natural log, all right, which means I'm going to get ln y equals the natural log of this big expression, minus 1 cubed over 2x squared minus 1 to the power 3 over 2 x plus 1 squared. Okay, so now remember, when you introduce logarithms, you can't introduce it to pieces of a function, right? So say, for example, you had this expression plus another one. You can't then say it's log of this one plus log of the second term. That's not how it works, right? It's the logarithm of everything on your right-hand side and the logarithm of everything on your left-hand side. Now we can use log laws in order to simplify this expression here. Okay, and I'm going to say, because you have division, division is related to subtraction in your log laws. So it's going to be your numerator minus the log of the denominator. Let's just do like that. Squared, right? So that's how it's going to look, right? So then I look at the first term, and you've got a power here, and according to your log laws, you can put that power in the front of the natural log. Minus, and in this bracket, that minus mustn't be there. That's a mistake. That must come out. Okay, what you've got here is you've got multiplication. Multiplication is related to addition. So we'll have 2x squared minus 1, 3 over 2. Okay, so what I want to do here, let's put the bracket here, and it'll be plus, that bracket will go there, x plus 1 squared. Okay, so then this bracket here is this one, the second term in this line. These are the same thing. It's just this line is the expansion of this expression here. Okay, then we can go even further. The first term is simplified as far as you can go, minus 1. So that's going to minus, that power can go in the front of the natural log, right? And that power can also go in front of the natural log. Okay, and then lastly what I want to do is I want to multiply out the minus sign. So then I'm going to write this as 3 4x minus 1 minus 3 over 2 ln minus x plus 1. Okay, you have to be very careful with minus signs like this, because often what students do is they forget this, right? Then they leave these brackets out and then they keep the plus sign, but that's not right. You must remember that that minus has to be multiplied out into the bracket. Okay, so be very careful of that. I'm going to add ln y here because at this point I'm going to find the derivative. Okay, because I've simplified as far as I can go. So I can now find my derivative. So the derivative of ln y is going to be 1 over y. Y itself is a function of x, which means it's going to be dy dx. Okay, then the first term is going to be 3 times. The derivative of ln is 1 over 4x minus 1. The derivative of the bracket, because remember now this is going to be chain rule, is going to be 4. Next term is going to be 3 over 2. The derivative of ln is 1 over. The derivative of the bracket, because you have chain rule again, is going to be 4x. Then our last term is going to be minus 2 times. Derivative of ln is going to be 1 over x plus 1. And the derivative of the bracket, because again, chain rule, is going to be 1. Okay, so let us simplify here. We've got 1 over y dy dx. And this is going to be 12 over 4x minus 1 minus that times that is 12 divided by 2, so you've got 6x over 2x squared minus 1 minus 2 over x plus 1. Okay, now the next step you mustn't forget, right? Because remember, you are looking for dy dx. You're not looking for 1 over y times dy dx. So we have to just move that up. So then we say, therefore, dy dx is going to be y times this, right, minus 6x over 2x squared minus 1, x plus 1, and then y is just the original function. Cubed over 2x squared minus 1 to the power 3 over 2 x plus 1 squared times this big bracket. Right, and that is your derivative, right? And that would be the solution to the question. Well, I hope you found that useful. Please let me know if you did, or if there's something else that you would like me to go over as well. And I will see you next time. Bye.